Hey, so it's noon sharp, quite. So I'm Paolo Ciuccarelli. I'm the founding director of the Center for Design. And good afternoon, everyone, and welcome to this last installment of the Conversation Spring series of the Center. And the aim of this conversations is to unite people and to gather people around a topic that speaks about interdisciplinary design research or interdisciplinary research through design. So we had a series of installments this spring, as you can see here, starting with musical thinking and design and sonic experiences. Then we moved into public space, public art, community-based innovation and architecture, and then transitioning to a totally different space: health, epidemiology, information design, media, journalism, and then dance and performing data and data embodiment, as we call it. And now today, robotics, design, and the future of work and the work environment. Thank you, Kristian Kloeckl, for assembling such an amazing panel, and the floor is yours for introducing them. Thank you, Kristian.
Thanks, Paolo. Welcome everyone to our panel on design for collaborative robotic environments. First off, thanks to everyone at the Center for Design and at CAMD for helping to organize this series of conversations. They've really contributed in a great deal to foster and facilitate interdisciplinary conversations, both during these conversations as they happen live, and also afterwards, since all our recordings of these talks are published and so accessible to people that are not able to join in time. I'm Kristian Kloeckl. I'm associate professor at the Department of Art and Design and the School of Architecture. I direct the Experience Design Lab, and I'm a member of the Center for Design and the Institute for Experiential Robotics. This panel is really about how we can design for humans and robots working together. And this has become an issue due to an exciting shift that has happened over the past few years, where some in the robotics community moved away from the aspiration of full automation and instead moved a bit towards exploring and inquiring how collaboration can happen between humans and robots, leveraging humans at their best as well as robots at their best. Today, robotic systems and devices are becoming ever more pervasive in many workplace environments, whether that be knowledge workplace environments, creative workplace environments, industrial workplace environments. And rather than being machines that force their modality of operation upon workers, the promise of these new robotic devices environments is to create responsive systems that adjust and adapt their operations to human practices and supporting the emergence of new forms of work. And in this new condition, many profound questions emerge. How should machines work if they can adapt to human behavior and needs? How do workers want to work, as that is no longer limited or constrained to how machines work? Who gets to make decisions in this process of collaboration? Is it the human? Is it the robot? Is it both sometimes? And then how do we design for both humans and robots to understand one and another at least well enough to carry out some of these activities together? Now, to discuss these and other questions, we have a wonderful panel of speakers today, and I'll be now introducing each of the three speakers briefly, and that will be followed by a 5 to 10 minute presentation of each of the three speakers before we open up the panel conversation. Our first speaker is Daniel Cardozo-Yac. He's an associate professor of architecture at Carnegie Mellon University, and his work explores issues ranging from social and cultural aspects of automation in design and construction, the politics of representation and participation in software, as well as new methods to understand design as a socio-technical phenomenon. He's the author of Pillars of the Vision, Software, and the Imagination of Design, and his work has been supported by the Graham Foundation, Canada's Social Science and Humanities Research Council, as well as Google's Artist and Machine Intelligence Program. Daniel is a 21-22 Pennsylvania Manufacturing Fellow. He has been a research fellow at Leuphana in Germany and a visiting scholar at the University of Cambridge. After his presentation, we'll hear from Keith Evan Green. Keith is a full professor at Cornell University in Human-Centered Design, Mechanical and Aerospace Engineering and Information Science. And Keith's Architectural Robotics Lab investigates a new frontier in human-machine interaction, which is meticulously designed, increasingly intelligent, cyber-physical environments that support and augment us at work, school, and home as we roam, interconnect, and age. In architectural robotics, computation is embedded in the physical fabric of our living environments, manifested as robotic devices, furniture, and rooms. And with support from NSF as principal investigator, Keith and his ARL teams generate new vocabularies of design and new understanding of human-machine interaction in a spatial realm. Keith is also author of the book Architectural Robotics, Ecosystems of Bits, Bytes, and Biology. Finally, we've got Tashkin Padir on our panel. Tashkin is an associate professor in electrical and computer engineering at Northeastern University. He is the director of Robotics and Intelligent Vehicles Research Laboratory, and also the founding director of the Institute for Experiential Robotics at Northeastern. His research interests include supervised autonomy for humanoid robots, shared autonomy for intelligent vehicles, as well as human-in-the-loop control systems with applications in exploration, disaster response, personalized in-home care, as well as nuclear decommissioning. And with this, I'd like to welcome our three speakers, and would like to hand it over to Daniel to share with us his presentation. Thanks, Daniel.
Thank you, Kristian. So let me see if I can share my screen. Can you see like a gray screen right now? Great. So thank you again, Kristian, for the invitation to this wonderful conversation, and Paolo for the context. I'm so excited to be part of this conversation and to learn from my fellow panelists about their work. I'm going to be telling you a little bit about the project that is relatively recent in my work, that in a way I feel like we're still kind of laying the groundwork for this project. It's a project supported by the Manufacturing Futures Institute here at Carnegie Mellon, and by the Pennsylvania Agency for Economic Development, around the subject of manufacturing futures, right? So within that broader umbrella, we are working on a project to rethink automation in construction, to place emphasis, just like what Kristian discussed, away from sort of full automation and moving towards scenarios where there are more adaptive robotic systems. This is a collaborative effort. I am the PI, but I am working in close collaboration with co-PIs Jean O in the Robotics Institute at Carnegie Mellon, and Dina El-Zanfali in the School of Design at Carnegie Mellon. Dina just joined the team, and we're going to be continuing for the next year in this project. So basically, yes, we're trying to explore the convergence of AI and robotics to enable more adaptive systems for robotically supported cooperative construction. I want to emphasize that term that we're using. We are not thinking of co-robotics or robots that collaborate with people. We are thinking of robotically supported construction practices. So instead of human in the loop robotics, we're thinking of robots in the loop construction. So we're interested in harnessing the increased digitization of design and construction processes to create new kinds of human-machine workflows, and to enable new forms of building that are not merely efficient, but also humane and social and environmentally sensitive. For example, something that is central to our work, and I suspect that my fellow panelists will explore a similar idea, that it is essential to acknowledge existing forms of expertise within construction sites and within workplaces in general, and take that as a premise of what may become the crafting of new technical roles in both the design and building domains. From an architectural perspective, we are particularly interested in how technologies may help us think holistically about the design and construction processes, making fabrication, manufacturing, and materials more visible as part of architectural and design workflows. So basically, this arrow on the left, basically the the interface between material production and the definition of digital models for construction. So we think this is crucial, essential to sort of rethink how we design and build in this century. At a technical level, we're using a particular genre of machine learning, which is reinforcement learning, that has as a basic premise the idea of trial and error. Basically, the idea of an algorithm that can respond to changing environmental conditions or changing sort of inputs of data. This is an important difference with sort of conventional industrial robotics, in the sense that rather than relying on pre-programmed instructions or indirect human control, reinforcement learning has the potential to equip robots with a sort of real-time, stepwise decision-making capacity that can be exploited in the context of an unstructured environment, such as a construction site or a modular factory, and so on. And I think this is very important for the context of architecture and building, because construction sites, as many of you know, are notably dynamic environments. They are not laboratories that can be fully controlled or factories that can be fully scripted. So we think that there is promise in reinforcement learning approaches to develop applications and systems that can more dynamically respond to changing conditions and that can more efficiently and safely support human activities on site. Our approach has, just to give you a sense of the history of the project so far, our first experimental sort of setup consisted on equipping a series of agents with sort of macro actions that the system could dynamically plan and perform based on changing conditions in a particular site. These are simulations where we looked at a number of a variable number of robots, in this case drones, to perform basic elemental construction tasks such as spray coating or bricklaying and so on. So in our simulations, we equipped these agents with LiDAR sensor input, and we used common neural network architectures such as MLPs and CNNs to handle different kinds of inputs, and used an evolutionary strategy to gradually increase the difficulty of the learning tasks. So based on this basic setup, we were able to show that this kind of reinforcement learning approach had the potential, or suggested a potential, to be scalable, to have like multiple robots collaborating dynamically in a construction task. And that gave us the sense that, oh, maybe this is interesting, maybe we should look into this more carefully. We published some results of this experimental work in Acadia last year. But of course, this is a very simple and simplified context, right? Like we are kind of working with drones where there's a few variables such as material and recharging and some basic environmental change conditions. So we're interested in how to address the broader complexity of construction. And this is the beginning of the project that we're in, the MFI supported project, which is exciting to us because we are working closely with industry actors. So we're working with PJ Dick, which is a very large construction firm here in Pennsylvania, and with Module, which is a modular factory company. And we are on the one hand embedded in their kind of workflows, trying to understand and converse with them and develop scenarios for application with them. And at the same time, in parallel to that, working with developing the technical groundwork for the reinforcement learning framework that we just discussed. This is like an outline of the project. This is how we're working towards task specification, and I can tell you a little more about that in a second. But yeah, basically we're working with them to define scenarios of application of this technology in conjunction with observations on site and ethnographic qualitative engagement with construction workers directly, and the definition, collaborative definition of benchmarks and sort of areas of concern or of interest, both from their side and from our side as researchers. We have around a minute and a half left, so I'm going to sort of walk you through some of the technical elements or how we are kind of organizing the work. On the one hand, there's this notion of sites, being close to the site. This is not a project that is developed exclusively in the lab, but also looking carefully at practices, situated practices of construction. On the other hand, part of the team is looking at the interface between digital representations and the robotic agents that we're designing. We have PDT, pedestrian detection and tracking efforts going on, localization, and so on. And the integrative framework for that is like the core technical aspect of that is a reinforcement learning, social navigation approach. This is to give you a sense of some of the ongoing qualitative studies that we're doing on construction practices. We have been paying close attention to three tasks: one, fireproofing; the other one, the frame for concrete pouring; and the third one, the cleanup of a construction floor, as places where we're focusing our attention to understand how workers are collaborating in the definition of those tasks and in the execution of those tasks. And we're doing that through kind of a series of interfaces. This is to give you a sense of the localization and mapping routines that we're kind of incorporating in the robot, so that the robot can have like an understanding of the site and so on. And all of these threads are hopefully converging in the next few months into a full-fledged demonstration on site. Let's move on. Similarly, the pedestrian detection and mapping, and crucially, the social navigation component of the robot. Again, construction sites and modular factories are places populated by human workers. We want the robot to be able to kind of navigate those spaces in a way that is safe and effective. So we're using social navigation algorithms developed here at Carnegie Mellon in the CMU big group as a sort of way of testing this technology. So I don't want to extend myself. I'm already above 10 minutes, so maybe I'll stop here. I think this was like an outline of the project. I'll be happy to talk more and especially to learn from my colleagues about their work. So thank you so much.
Wonderful. Thanks so much, Daniel. That was fascinating to see these details about your work. Next, I'd ask Keith to share with us his presentation.
Sure.
Thanks, Keith.
Yep. Let's see, hopefully something happening there. Are you seeing, it's only on one side. Oh, here we go. Let's see, we'll just do this. We should be on our way. So that, right, people can see things, right? Hopefully, right, good. Okay, hi. So I'm Keith Green from Cornell, and I'll get right into it about architectural robotics. So big picture, right? We live in cyberspace. This is what we often encounter when we're interacting with people. They're interacting with machines, these little machines that we carry around. And so the question is, if that's the world we're living in increasingly, right, an increasingly digital world, where is our home in it? And so my response is to develop, as Bill Mitchell said, a robot for living in, right? A robot that we live in that dignifies, enables, and empowers us. And as Kristian mentioned, I wrote a book about this. I didn't know even if there was a book to write, but MIT Press convinced me that there was. So some years ago, I wrote this book. And the question is, for whom? Whom is architectural robotics? And we'll define architectural robotics in a minute, but we understand by those two terms together, right, that it's something about architecture and robotics, right? So we're really thinking about a diverse human population, right? And what are they doing? Well, they're engaged in wicked problems under determined right? Problems of living, learning, playing, working, moving, aging, and other things. All right. And it's really a design problem. I approach this as a designer. I'm in the Department of Mechanical and Aerospace Engineering. Yes. My home is in human-centered design. I lived in architecture schools for most of my career. Had a joint appointment also previously in electrical and computer engineering, and I'm in information science, but I approach this as a designer. How do we approach problems of living and opportunities of living? And so what does this look like? So again, we only have a few minutes together for my part of the presentation. So I have this composite, really, a little homage to Aldo Rossi, but in this millennium that we're in. Various projects for older folks, for children, for subgroups that maybe are misunderstood, and also savvy people working together, co-located with a computing platform. So these are some of the projects. I think most of these were in the book, so they're a little bit past tense. We're doing a lot of new things, but it gives you sort of a breadth of the landscape that we're working in. And this is very collaborative. I think it is apt for the topic of today, which is a collaborative environment that has embedded robotics. How do we define this finally, right? Few ways. Architectural robotics may be defined as meticulously designed, robotics embedded physical living environments, computation that becomes spatial, right, enveloping us. And then from someone that I shared the stage with in Delft for a conference as a keynote, Catherine Hale, she speaks of cognitive environments. She said, what you do, Keith, is you develop cognitive environments that at least aim to grow, think, and act with people. So why do we want this? You know, it's easy to say that we have robots and we have architecture, we put them together and that people are going to love them. But it's nice to know that there might be some motivation for developing such things. So I'm going to just speak very briefly about 5 human dispositions for architectural robotics. The first being psychological, that human beings are protean, they're fluid and adaptive, many-sided, and that we seek, human beings seek many and new places to exist. From an evolutionary disposition, we have exhibit adaptive flexibility. We've emerged as a species that has the capacity to buffer itself and adjust to environmental dynamics. From a learning disposition, the brain wants variation, it wants movement, it wants change. That's how we learn. And then from a poetic disposition, thinking about Marinetti at the beginning of the Futurists, right? We have, as Marinetti put it, we have a burning passion for the coming into being of things, a framework we can consolidate always differently. And finally, an emotive disposition, that machines don't always have to be high performance, high performing, functional. They might have a lighter side. They may actually afford people a little bit of pleasure or fun, and that might be an aim. So let's consider some fundamental questions. Again, I'm at a fairly high level, and I'm trying to be a little bit more here theoretical. I'm only going to talk a little bit about individual projects, but let's consider some fundamental questions about all of at least what I'm doing. All right, intelligence, how much, right? I think we're sliding in my lab a little to the right, but I think we place ourselves somewhere between a Roomba and, of course, this sort of hope for the singularity in this humanoid, right? And then the relationship, right? If we're dealing with a humanoid or we're dealing with a little robot vacuum, we're really dealing with something our size or smaller that we can commandeer. But when you talk about architectural robotics, we're dealing very much with a new human environment relationship, a different kind of human-computer interaction, right? Because it's all around us, right? It's not a one-to-one relationship, right? But something that envelops us. We think of the words of Walter Benjamin from the famous essay, right? That architecture is consummated in a state of distraction, right? As opposed to objects, right? Which we more or less commandeer oftentimes, right? How figurative, right? The Roomba vacuum is a little pill-shaped object, right? Rather platonic. On the other side, we have Paro, the robotic seal, and I think that we could be somewhere again in the middle and probably leaning a little to the left. And then how rigid? What kind of robotic systems are these? We do work sometimes with rigid robots, but we tend to design things that aren't rigid because they're so close to us in unstructured environments where all kinds of things can happen that are unexpected, right? And if these surfaces and shapes are compliant, then perhaps we have less risk when we are intimately engaged with them. So I was asked, once I've been describing this for a long time. What is this all about? So I made this GIF, right? We've got this humanoid robot, could be Kismet. It's a rather odd menage a trois here. I don't know what Truffaut would say of this, or I guess he did. But we thought, well, maybe we put a humanoid robot in the center and do maybe a rather French thing with it. Take off the limbs and the head, right? And distribute these, right, in a room. Of course, it's April Fool's, so I'm having a little fun here. But here we are, a distributed system, right, of robots, the humanoid as a distributed system, right, a cognitive, distributed, networked system, right? Maybe that's a good place to live, right? And also, you don't have to add a robot to the system. The robot is already embedded in things we naturally have long lived with, like our furnishings, right? So you get older, you need a robot. Do you really want one to roll over the threshold that looks a little like us? Or do you want this functionality already in the space, in the things that we have? Okay. So I got just 4 slides on these. I'm going to show you 2 projects in a little bit more detail, 2 slides worth, right? But we're asking the kinds of questions like these. What work environment co-locates multiple tech-savvy workers in one place, right? So not a one-to-one relationship, but a computing platform that invites us to work together. So we created this is very much the beginnings of the lab many years ago, a robot room we call AWE. It's really a workstation supporting working life in a digital society. We might ask then again a question, how that literacy is an enormous problem, and then the question is, how can literacy be cultivated in an environment that becomes a book, right? A printed book. All right, so we begin with a printed book and we tell stories in it in a library, in a typical read-aloud with Title I kids that have often many times literacy challenges across the US and even in the Netherlands, where I was teaching for a while. It's a larger literacy issue there than one I would ever imagine. And here we are in this lit room that evokes the nature of the book, the atmosphere of the book in sounds, movement, light, shapes, colors, right? And then the kids, then it serves this room as a scaffold to literacy, as a read-aloud expert reads a book to children. And we tested this with scores of kids over many months with educational PhD, MS students helping us with the interviews and other measures. And anyhow, presented that at DIS a few years ago in Hong Kong. So the vision, I'm getting to the end of this already, right? What's the vision of architectural robotics, right? We can start with these kinds of things. I'm not dismissing the Roomba robot or the humanoid, if we can ever create one that actually we can afford and act as some of the things that we think, some of us think they might do. I'm not so sure. We'll get there very quickly. But we think that we could put these things together in this sort of landscape, right? And we could add the other things or just recognize the other things that are already in the landscape, like the various devices that we have and nature. And also that we ourselves are becoming, in a way, post-human, right? And I like to think of the things that we're developing as, to borrow the words of John Cage, a garden of technology, where each inanimate object has a spirit. And so the spirit of all this is to think of ecosystems of bits, bytes, and biology, right? And here I'm borrowing the words from the 60s from Richard Brautigan, a marvelous poem. I won't play it, I'll just read these few words and we'll move on to the next speaker. But he speaks of this vision of a cybernetic meadow where mammals and computers live together in mutually programming harmony. And so that's what we aspire to, And that in a few moments is a little bit of what we do in the lab. There's the book, and we have a website. We have lots of new projects on the website, papers, videos, and all kinds of other fun things. So come visit us that way, or come to Ithaca and say hello. Thanks.
Thank you so much, Keith. I love the way you created this web of relations between architecture, design, and robotics. And I did not miss your quotes coming from the field of music, knowing that you're a musician yourself.
That's right.
So that was great.
Thanks.
Thank you. Tashkin, the floor is yours.
Excellent. Thank you very much. So let's see. If I here we go. Well, good afternoon, everyone, or good day, wherever you are. Again, thank you, Kristian, for inviting me to this panel. And I want to make the case, for experiential robotics today, which is our brand at Northeastern University. And to do that, I want to first give you an idea what we mean by experiential robotics. To us, there are four inseparable elements of experiential robotics. I hope, when you first heard the term experiential robotics, you found it a little bit unexpected. Where did this come from? And you wanted to know more. That's our, immediate hope. There are four elements of experiential robotics, and it all starts with the human experiences. It is not about robots. The experiential robotics, the field as a field, it's not about robots. It's about the humans. It's about the human experiences, from aging in place, from how we interact with our, self-driving cars, transportation, societal problems, hard problems, to infrastructure. I was very happy to hear about Daniel's project on, integrating robots into construction, but then we also have the aging infrastructure. Sustainment is another big piece of the entire deal. And it all starts with how do we provide ourselves, the society, with better means and ways of doing our jobs. Having, entertainment, right? Experience is such a loaded, such a encapsulating term. So we start with human experiences, come to the labs and develop the technologies, and we have a very broad definition of what a robot might be, and then go back and experiment and really validate our solutions with the question: are you better off? Do you now have a better experience because you have your robot companion next to it? So that's element number one. The second element, I use the term, the cliche, learning robots in this slide, but robots that learn from their own experiences. It is so, the paradigm so far is, yes, we are using machine learning, more and more these days, but then we have prescripted algorithms. We have algorithms that fit perhaps one size or two or three, but not all situations. We want to push the limits, and I know, this is the hardcore robotics challenge. What happens when we introduce our robots into novel environments, or we present them with novel objects, novel tools? Can they learn? Can they figure out what to do with it? This is the second piece. The third element of experiential robotics, now you get the feel about who Tashkin is. I'm sharing the title of my declined career proposal from 8 years ago. We funded this work in many other ways, but the third piece of the third element is robots learning from their interactions with their companions, with their collaborators, with whoever they are next to, right? Again, I always chuckle when, we start talking about autonomous, and I ask the question, what is autonomy? Who's autonomous? Kristian told us show up at 12, for this panel today, right? So, we have a calendar that we follow and so on and so forth. So the personalization, systematic or non-systematic, is a key aspect of experiential robots. They learn from their interactions with their companions, because I always claim this, a human-robot interaction may not be the same, change the human, and it won't be the same, with the same human at 8 a.m. in the morning versus noon versus the evening. And then the last piece, which is still critical in my opinion, is getting our researchers out to the lab and get them or equip them with the experiences that they are trying to transform. So in this picture, Kristian is chuckling because this is our team, here. You are not looking at seafood workers, okay? These are actually, one PhD student, two, researchers, postdocs, and research scientists, and myself. We are at the lobster processing facility down in Fall River, Massachusetts, just to learn what do workers do and what is hard for them, and is there a way for technology to come in and intervene. So 4 elements, and they are not inseparable in my opinion. You cannot just pick and place and say, okay, so we will just do this, we'll just eat the strawberry ice cream, from that bucket that I showed you. No, we wanna really go for all 4 elements, that these are the projects that we are after. And why experiential robotics? I guess, up to this point, both speakers emphasize this. We have hard problems. Future of work has become today when COVID hit, right? So every one of us wanted to stay home, and we still want to stay home, but we still want to be able to do our jobs remotely. And if the jobs require physical tasks, we want to have our avatars. Manufacturing, supply chain disruptions, we couldn't produce our own masks early on, or even if we produced them, we didn't have the supply, the reliable supplies, and then we didn't know if they were good or bad, and so on and so forth. First and last mile ecosystems is getting more complex. Workforce shortages never disappeared, actually, right? So there were certain jobs, there was, we all hear about unemployment at all levels. However, companies, if you talk to manufacturers, makers, they always had jobs available with certain skill sets. So on and on. I don't want to, I don't want to spend too much time on it. So at the institute, that I happen to be the flag carrier, but then Kristian is a part, and then I noticed a number of our core members are here today. We have number of research trusts where we look at really human-robot teaming. Where we look at embodied AI. Yes, we are interested in machine learning and AI, but really, what can we transfer from those theories and foundations to actual physical robots? We are interested in new systems design and control. A robot doesn't look like a robot arm. It doesn't look like, need not to look like a humanoid. An entire environment, Kristian is going to again probably, hopefully smile. An entire environment can be a robot to enable the vision. Security and privacy in almost all applications are critical. We are not really ignoring that piece. It cannot be an afterthought as far as we're concerned. You're going to bring it today. If you're adding cameras into a 75-year-old person's home, private rooms, and so on and so forth, you're going to consider how do we provide this, preserve the privacy. And again, not only ethical considerations, but policies and economics of deploying those systems within global frameworks. So with this in mind, I want to talk about 2 very brief examples. The first example is a project that we've been working on for more than a decade, and I believe this is one of the best illustrations of what we mean by experiential robotics. It started off, okay, here's the Amazon fulfillment center, and here's a worker, a healthy worker. what if we want to provide a similar experience to a worker who is mostly healthy, however, has a hand amputation, doesn't have one of her hands? Can we still provide a smooth and interactions with the environment and basically the ability to complete the task? When we first put in this proposal to the National Science Foundation, I said, look, this is such a crowded area. They work, there are a lot of big players, in this research. What should we do to differentiate ourselves? And I said, our likelihood of getting funded is small, but it got funded for almost 5 years. And it was a large collaborative effort with Northeastern, Worcester Polytechnic Institute, as well as Spalding Rehab Hospital. And we said, a prosthetic hand is interesting because it is the, Keith, I want to call out your sliding scale. Your intelligence, your robot may know what to do, but it is still moved to places by a human arm, and we do unpredicted things. My approach might be totally different than, Kristian's approach to objects. So rather than starting with, oh, let's add all these algorithms, cameras, and sensors to this robotic arm or hand, let's understand how do people reach to get to places. And we collected data. We collected data from a number of people just to understand what happens when we reach to grab our phones or our coffee cup. And we found interesting aspects. We reach the maximum speed of our hand. Our hand reaches its maximum speed right around the 60% mark of the trajectory. Now, that's a data point that robots didn't have in the past. And we really didn't wire that into that capability into the robot. So that gave us a starting point. But then we also said, look, a robot might, a robot, a true companion, a true experiential robot need to learn from the human preferences. Sometimes I reach with my right arm or left arm. I may have 2 amputations, but then as that success rate grows, maybe robot adjusts that 60% mark, and that becomes a truly experiential robot. So we didn't sit in our labs. Our researchers talked to individuals with amputees from the US and Canada. We really developed a pipeline where the robots can learn from their own experiences. So, we can introduce small objects, large objects, and figure out what type of grasp will move it. And then the robots learn from the human experiences because everyone's reach is different. Oh, by the way, the overall goal here was to minimize time to grasp, right? We have technology demonstration right now. You can reach over and then make a gesture, flick a muscle, and then actuate the hand. But our goal was to minimize that pause where again, between the reach and the grasp. My student graduated, we demonstrated this, and published the paper, and it worked. I don't think that my videos are working today. Oh, they're working. So, we ran tons of simulations, but we also completed, actual real-world experiments in the lab. So that is, in my mind, that calls out as a experiential robotics. Very briefly, this is a collaborative project that Kristian, myself, Alicia Modestino Sasser, John Basel, and Kemi Jonah are working on through the NSF's Future of Work program. The story is straightforward here. I mean, it's not a story. The problem is straightforward. In the US, we have a $20 billion trade deficit in seafood. It's not because we don't have enough seafood. It's because we don't have the workforce to process it. We all like our little cut up, cleaned up, fillets, but then it takes a lot of effort to go from the whole fish to that packaged product. And what happens is a lot of fish is caught on our waters, and then they are shipped to other countries and then sold to the global markets. We approach this from a design from scratch perspective, and again, we didn't sit in our labs, and we ended up going and talking to, I guess at this point, more than 120, seafood processors, seafood companies, and et cetera, just to understand, what will the factor of the future should look like. We came up with a number of lessons learned, and this is Kristian's creation. The way that we approach this, again, I am an engineer, I'm a roboticist. Yes, I can see, but then, Kristian really brings in his design expertise and says, look, here's how it is done by a human today. And here are the individual tasks that happen. And we, create storyboards in a sense. And then we start looking at now, okay, so here is a task where we can bring in a robot to augment the human worker with an immediate goal of, number one, providing the workers with a better experience, and number two, increasing the productivity in this really challenged environment. This is our latest work where we looked at a straightforward, simple, handover task, but then we work with, and this is a paper that we just submitted, we work with collecting human biometric data to provide, number one, a better ergonomic posture if it's preferred. Number two, perhaps there is a way to stimulate the human workers' movements. I mean, at the end, they maybe get some exercise out of it, or maybe they feel better about the job because it's not that dull and straightforward. Okay, with this, I'll stop here, and happy to answer questions.
Thanks, Tashkin. Thanks for your presentation. It was great to see, and in fact, it was nice to see our research team in the seafood processing gear, since we'll be back there next Friday in Boston Seaport with the group again. Thanks everyone for these wonderful presentations. I think we covered lots of ground. Some points stuck out in several of your presentations, and I've got a large number of questions, but I'm going to try to keep it to a few. I want to start with Daniel. You talked about the robot in the loop, and that's obviously a wonderful inversion of the much more common term of human in the loop. Can you tell us a bit more about your thinking behind this inversion of the approach and issues of symmetry of human-robot collaboration that you see that seems to be at the basis of your work?
Thank you so much, Kristian. Yes, yeah, inversion is a good way of looking at it. I think that like one important premise for the work that we're doing in this project is to tactically avoid the notion of human-robot collaboration, because it sort of automatically implies a sort of symmetry between humans and robots in a work context, and that symmetry, I think, can be useful as a sort of a useful device to communicate the vision of this kind of ecosystemic relationships between humans and robots. But from our perspective, it also hides important questions that are important for this particular project, and I believe in general to think about human-machine interactions and configurations. On the one hand, it hides the fact that robots are not humans; they're not autonomous in any meaningful sense of the word, and I think Tashkin began his presentation with a fantastic kind of play on that idea as well. The notion of autonomy is complicated. For us, it's important to remind ourselves all the time that even that every performance of the robot is carefully orchestrated. It relies on very kind of specific practices of data collection and curation and development, and that those carefully orchestrated performances of the robot, even when they look improvisational, are the result of a lot of design decisions. So we want to forefront those decisions, make them part of the conversation, and that's why we, along with the robot in the loop notion, we're working with the notion of robotically supported collaborative construction, right? So again, thinking of robots as resources in the context of work, in the context of human action, rather than as humans or equivalents to humans, so to speak. It's a tactical decision that has to do with those ideas.
That is so interesting, and I wonder what Tashkin and Keith may respond to. It seems a small shift that I think is actually a really loaded point. As the work of people from different domains, robotics, architecture, design, and other fields come together that each have their legacy and history and values in terms of looking at working with machines, working with humans, working at the intersection with them. So just flipping it changes a lot, actually, I think, in how we can go about that. Keith, Tashkin, any response to that? Any thoughts on that?
I know in the HCI domain, right, there's talks of, not HCI, but human-computer integration, right? Which is a better term than interaction, right? And I think Daniel brings up a good point of this sort of like the idea that there's, again, a one-to-one relationship, that the robot and the human are on equal footing, and it's anything but, right? Yeah.
It seems to come also, go ahead.
Oh, sorry. Yeah, I also, Kristian, like your comment, or maybe it came from Daniel as well, that there is something about being an architect or an engineer or a social scientist that I think, especially students of ours, should maintain. I find I get architects coming from great pedigrees. They can go to Harvard and Columbia. And they come to me and they say, I don't want to be an architect. I want to be this other thing, as if somehow the thing they're not will bring some sort of magical wonder to themselves and their whole operation in life, right? And I said, you picked architecture and there's so much there. Can't you bring that to the table? And I guess, Tashkin, you talked about, right, having all these people and what Kristian was able to bring to your group, among other collaborators, I guess, right? And I think somehow there's a lot to be said for someone coming from some discipline, but being conversant with others from other fields. And in the longer run, like I have with a very long time collaborator of mine, Ian Walker, who's an ECE, electrical computer engineering, he has become a real pain in the neck designer. The first time we went to a conference together, he didn't notice the surroundings. We walked in the lobby, he didn't see anything. Now he says, could you imagine how ugly the color is of that lobby wall when we entered? I said, Ian, you've become a designer. And in many ways, I think I've become a roboticist. Some people think that's where I actually formally sit, when in fact, I don't really have I have basic sciences as a background, partly, but I don't have formative training as a mechanical engineer. So there's a lot to be said of respecting, right, your own discipline and finding a value of that in collaborative teams, as opposed to thinking that you have to cover all the ground on your own and go back to school in every area, and somehow where you began is not valuable. But
and just to add on to so I think we are also enjoying the fact that robotics doesn't exist as a discipline, right? So I mean, when you look at the whole problem set, knowledge base, there's no one engineering discipline that can claim, we are the roboticists, right? So that's why the conversations start at a level where everybody is somewhat equidistant sometimes, right? So and I remember the first conversations, Kristian, that we had. Okay, let's come to the table with an open mind. What happens is it takes a while for us to get to the same terminologies or a common, not the same, a common set of guiding principles. But then once you're there, then it moves forward.
Well, Tashkin, our connection really started once we sit down for coffee.
Yeah.
And you asked me what I did, and I told you that I'm looking at improvisation as a model for human interaction. And you responded, that's interesting. That's kind of what we're doing within robotics. And off we went. Keith, you gave us this wonderful panorama of robots in different shapes, forms, configurations, and scales and sizes. And you talked about robots being distributed, spread out, embedded, the surface of robot, and ultimately you talked about the robot to live in. Can you talk about the different design approaches for such different articulations? Do you approach work on robots and human-robot collaborations or coexistence in the same way based on these different articulations, or is there a difference? How does that work for you?
Yeah, just in a few words, because I know even Paolo, we have a hand up. So, Yeah, as I did with my presentation, we begin with problems and opportunities of living today, right? Some of them are new and some of them are persistent, right? And we start there as designers and say, what can we do, right? Which is different than architecture often does, right, Daniel? I mean, mostly we're looking for an image sometimes, sadly. And I think there's, right, and that's what I like to say about industrial designers or our friends sort of in interaction design, which is kind of what I've become, I guess, in a way, is that we start with problems that really are urgent and opportunities that are marvelous. And that's where it all begins. Tashkin talked about that from the start of his talk as well, which I think was a great way to begin.
Tashkin started us off with a photo of ice cream, and how can you not agree with anything that comes after an image of ice cream?
Yeah, that was great. Yeah, very nice.
Paolo, you've got your hand up.
Paolo has a question or comment, so I just want to.
Yeah.
Thank you. Being an architect by training, and then that's fabulous. Thank you very much for your presentations. And I was an architect, and then I moved into information design, working with computer scientists. But I still see the same issues that it's something that I really can't handle in a way. So it's about aesthetics, and someone mentioned Marinetti, and so is there a way to handle that, the aesthetics of that, in a way that is not, that we don't fall into the trap, I'm a little exaggerating here, of be seduced by the efficiency of technology? So meaning, if you look at data visualization, if you look at architecture, if you look at robots, the aesthetics of that, I think we are not managing that entirely yet as designers, as architects. And it happened with all sorts of technologies. So it's not new in a way, but it's happening. And I think we are not yet able to manage that. So how can we be better as designers and architects in that space, creating an aesthetics that is not just driven by the efficiency paradigm of all these technologies?
And maybe I'd like to jump in there. I think it's a wonderful point, Paolo. I wanted to touch on the question of disciplinarity that has come into the conversation, which is so fascinating and interesting. I think that there's a way to think about architecture aside from that concern with the image that, sadly, as Keith mentioned, has come to dominate so much of the profession, right? I think architecture has a history of being an integrative discipline that brings together different traits, different forms of technical and aesthetic competencies. And I think that architects have a role to play in that integration, right? And there's also something that I find very useful from my sort of architectural training as someone who runs a lab with roboticists and computer scientists and physicists and designers and industrial designers and so on, is that there is a concern with site specificity that is instilled in the architectural training that is very enriching and very different from what a scientific or engineering training gives people. There's a sensibility about context and site that I find very valuable in the context of technology design and production. And that's something that we try to hear in our lab, like emphasize, even with people with very strong technical backgrounds, the importance of site specificity, the importance of not designing technologies in a vacuum, as all of the examples we saw today are wonderful examples of that. But I found that a very useful technique that I associate with my original roots in architecture. And yes, I just wanted to say that.
We have a very simple motto in our lab, and that got developed over the year. If it doesn't look beautiful, it won't work beautiful. Now, of course, this is very, I mean, it's a guiding principle. But what does beautiful mean? What does it mean to say it looks beautiful? I think, this is a personal opinion. I want to associate the look and the shape and the form of the robots to their functionality. Right? If I don't know what that robot does, that gives me that eerie, perception perhaps. But if I see it and I say, okay, I see it, this is a low profile robot that's on the floor, it's going to probably vacuum, or I mean, if we can start with that, and then there, I think that design space is wide open, Paolo. If you go back to it. Although my research has been on humanoids for, I don't know, for quite some time, I'm not sold on the idea that the humanoid robotics form and shape is the best for every task or every job, and so on.
I think perhaps you can talk a bit about that, Kristian. You put in that form follows function, a bit principle for robotics. And what Keith is doing seems to be quite different. When you talk about robotic environments, robots to live in, where the robot seems to disappear and clearly there's no more form following function. What is the tension? How does that work out then, Keith?
Yeah, well, I was going to respond to Paolo. I would say that, and I sort of under the surface was in my presentation when you saw Maradere, but and well, really Jean Tingley, because the last of those 5 kind of dispositions of human beings for this thing was a Jean Tingley sculpture, right? So this is the Swiss artist that would take this sort of industrial refuse and assemble it together for fun. Right. Mm-hmm. And I have a little paper at one of the ACM conferences I wrote on using contemporary dance, for instance, as a way to think about the way robots might move through space. Why do they have to move like we walk? Right. Why that? Can't they do something else? Maybe dancers, even if it's a very beautifully awkward dance. And I actually took a particular work that I saw at MoMA. Or the Guggenheim or something. I think actually the Whitney, but and I found that work and said maybe we can have a robot move more like those dancers, which had that sort of awkward grace that seemed to be more like a robot might move. And I also look a lot at Black Mountain College and people like Rauschensberg, Cage. Chance operations, Merce Cunningham being sort of a paternal figure, I guess, for modern dance, and say, might we think about how robots motion plan, right, in accordance with sort of these other ways of operating, more unexpected in a way, and maybe the intelligence is more of a robot's intelligence than a human's. Right? It is supposed to be artificial intelligence, but we seem to keep thinking about human intelligence when we design and program robots. And I think we get caught up again a little bit in the disciplines, right? To think that a robot does look a certain way or architecture looks like a certain way. I think maybe we have to design standing on our heads, literally, and we might do better.
We've got time for 1 or 2 more questions, or Daniel, go ahead.
Yeah, I wanted to take a moment to address a question that Nicole posted on the chat a moment ago about whether we had in our team considered the potential impacts of this type of technology in the construction site. And I think it's a very important question. It's a very, like in terms of labor, I think that's where the question is moving towards. It's a question that is very important for us. We are wary of the risks of de-skilling that kind of are often associated with the introduction of robotics in industry. We have taken some steps to guard our project against this type of readings or this type of potential outcomes. And they have to do with things that I've been trying to kind of emphasize: the idea of envisioning robots as supportive of existing practices, avoiding frames of monitoring and surveillance, which are very common in the world of construction automation, right? If you look at the construction automation literature, a significant portion of that is devoted to systems that surveil workers and sort of bring like a Taylorist logic to the construction site in order to schedule and sort of optimize. We are avoiding that. We're instead trying to think of robots that are easily configurable by individual workers in support of specific practices. Our ethnographic engagement with the construction site is one way we're trying to address that and to make the technology design process more collaborative, right? So in a way, I feel like this is one reason this project is interesting to me, is because it's also an experiment in technology design process. And of course, there's a lot more to talk about, but I wanted to briefly address that.
And I just want to echo what you mentioned in one sentence. I made a big deal out of being experiential and go out and talk to everyone. However, the danger or what we come back home is usually, wait a minute, the problems that they have are so grand. We don't have the technology even to start with, right? So some of them are maybe a decade out. I mean, the capabilities, right? So knowing what robots can do and what they cannot do. So then it becomes an iterative process where you go back. Okay, so now let's take a look at. So that's why the storyboards that I like, right? Because then you can see, look, we cannot do this, but then how about this? Is there value to this? And then there was a question on the business models for adoption. And yes, in our, especially the seafood processing project, we have an economist, labor economist, looking at what will it take for companies to adopt this technology. And secondly, where is the break-even point, right? So is it, is it worth it?
Great, thank you. Thank you, everyone. This was a fascinating, I would say, start of the conversation. A lot of interesting overlapping topics and topics of discussion came up. I'd like to really give a big thank you to Daniel Kurtulyak, Keith Green, and Tashkin Padir for joining this conversation today. Paolo, Center for Design, and Kambi for hosting us. And for everyone, keep in mind that this video will be online at our Center for Design, together with all the other previous conversations and future conversations that are really conversation starters. Thank you, everyone, and see you soon.
Thank you.
Thank you so much.
Thank you.
Thank you.
Thank you.
Thank you.
Bye-bye.
Bye. Take care. Yeah.